Okay, first I would like to welcome everyone to join this course, CS 46000, the programming language course. We have a subtitle of Structure and the Interpretation of Computer Programs. Okay, this one actually is a name for the course or course, and we'll talk about it. Okay, why this subname is there. So welcome to this course. First, my name is Eric Chow. Okay, I'm currently IEEE senior member and member of the Computer Science Teacher Association. I'm also USA Taekwondo and AAU coach. I coach my sons and for Taekwondo competition. And then I graduated from National Taiwan University and in computer science and engineering. And then I came to USC for my master and PhD program in electrical engineering and computer science. And then after that, I've been a IEEE member since 1990s. Okay, so I already an IEEE member for more than 35 years. Okay, where I'm living right now is I'm living in Fremont. Fremont here, this is the map of the Bay Area, San Francisco Bay Area. So I'm living on the East Bay. So if you are not familiar with Fremont City, if you know about Tesla, okay, so Tesla is located in, Tesla has a big factory in Fremont City, okay. I would say it's the first factory of the Tesla is in Fremont City. Its headquarters was originally in Palo Alto. It's a opposite side of the bay around the Stanford University. But later they moved the headquarters to Texas. Okay, so but they are originated from South Bay and East Bay. Okay, and Tesla has the first factory in Fremont City. So this is Tesla's factory from the freeway view, freeway IA-80, okay? And my hometown, okay, where I grew up, if you know about TSMC, okay? TSMC, Taiwan Semiconductor Corporation. Today it has a big drop because like media and the whole tech sector is jerking down because of the DeepSeek, okay? We will talk about it maybe a little bit today. Why the stock price dropped and what happened. But anyway, it's located about 15 miles south of the capital of Taiwan, Taipei City, about 15 miles. So it is actually TSMC's headquarters is located in my hometown, okay? And then there are many high-tech company over there, okay? So probably has the highest density of the number of the IC manufacturing factory over the world, okay, right now. Okay, first let's look at this diagram. This block diagram is about the courses in computer science, okay? So right here, I'm separating the computer science courses into hardware, software, problem solving and programming and theory, 4 different important track, okay? And then where the programming language course, this one's 46,000 is being placed is right here. So basically, when you study computer science, you learn some language, okay? You learn maybe Python, maybe C, maybe Java, okay? You learn one of the language, and you learn number one, programming essential, the basic loop and function, and also if then else, the decisions. That's the number one. And then you go to level 2, you learn object-oriented programming, you learn recursion, you learn sorting. Okay, that's the level 2. And then you go to level 3, you learn data structure and algorithm. Usually nowadays, these two are one course. When I was in college, data structure and algorithm are two separate courses. Okay, but now they combine them into one course. So you can consider this one as a level 3 programming course. Okay. Now, programming language is level 4 programming course. And after programming language, you can go for compiler design. So the relationship of the programming language and data structure and the compiler is programming language is a design of the language. It depending on the knowledge of the data structure and algorithm. So in this course, we will need you to do a lot of programming, and they will depend on data structure and the algorithm. So this one is actually one of the language up to level 3 will be a prerequisite for this course. Okay. So this actually is level 4. So programming language, the main topic is the design of a programming language. So we talk about the features of many of the programming languages. And also we'll talk about how to design a language. And then the implementation part is a compiler design. So usually programming language and compiler, sometimes they are combined in one course. Okay, sometimes they are combined in one course, but sometimes they are separate. And I suggest that you take the programming language first and then compiler and design. And compiling a programming language course, usually it is a required course in computer science curriculum. Okay, so some students may wonder why I need to take this course. And some students actually say that they take this course just because that is a required course in computer science, but they don't know why this course is a required course. So what I can say is that this course is a level 4 programming course, and it actually is a very centerpiece of the computer science discipline, so it's very important. Other than the problem solving and programming track, you will need to know about some hardware, like including the logic design, computer organization, computer architecture, microprocessor lab. If you are in computer science and engineering, you may need this hardware training, but and also you need to know about parallel processing. Nowadays, the multi-threading, multi-programming, instruction level GPU design are actually very important. So hardware is also very important. And then you need to know about software as well. So the software, we talk about software system. So software is software system and software application. So application, you can see is not right here, like graphic design, computer security. Those topic is not here. They are not considered to be the core courses of the computer science. They are applications. So it's a different story. So core course, we talk about the Unix, the OS operation system, database, and networking. Okay, these are the basic core courses for the software system. And then theory, you need to talk about math, decreased math, and also the formal language, automata, or computational theory. So these are 4 different things are the most important topics if you are computer science major. So why these are very important? If you want to see why I pick these 4 different tracks as an important topic, you can go for Google and you say Stanford Master of Computer Science Foundations. So you go to here, it has the Stanford Foundation requirement, Stanford Computer Science, just click it. So this page tell you that if you want to apply for the master program in Stanford, what is your educational background requirement? That is their foundation requirement. Okay. So if you have deficiency, they will require you to took it again in their master program. But anyway, let's look at the required course, like including the theory, logic and automata complexity. Okay, this one is the logic part. Probability, this is math. Okay, probability and statistics. This is now very important for AI now. And design and analysis of algorithms. So this one tell you the algorithm course very important. Level 3 programming very important. Computer organization, this one is the hardware. Okay. And then principle of computer system. This one is about operation system, networking, distributed system networking, and operation system. So basically, this foundation tell you what is required when you apply for master program. Most of the university, not just the Stanford, we require these different backgrounds. Okay, an application part is not in here because application part usually is courses that you take, and then you will go for a job. Then you need those kind of the course. But if you are going for master program, actually you can take it later when you are in master program. Okay. Otherwise, right now more important parts are these core courses. Okay, these core courses. So why so many boxes? These are the course name that I had when I was in college. Okay, it's divided like here. Right now, a lot of courses are combined. Okay, let's pick an example of the. Let's look at the equivalent course. That's actually UC Berkeley CS 164. So this CS 164 at Berkeley is programming language and compiler. So they combine programming language together with compiler. So these two courses, level 4 and level 5, combined together in one course. And their prerequisite is level 1 to level 3 programming background. Okay. Anyway. So this is the relationship of this course with other courses. Now let's look at the topic that we are going to cover and how this course have been organized. Okay. So how this course is organized, Unit 1, we talk about fundamentals. So fundamental is talking about what is a programming language, what is compiler, those kind of things. Okay. And Unit 2, we talk about data type and memory model. So each language would have a memory model. Okay. And then we'll talk about programming paradigm, imperative programming, functional programming, object-oriented programming. So these are in chapter 4, 5, 6, 7, 8, okay, whatever. One thing I need to talk about is, so right here, when we talk about Unit 2 and Unit 3, right here, in this course, we are using Python as the main example, okay? We use a Python as the main example. So why Python? Why I'm not using other language? Actually, Python is a good candidate. JavaScript is also a very good candidate. Okay. And these two languages are considered to be good candidate because they have the object-oriented programming feature. They also have functional programming feature. They also have good imperative programming features. Okay. So the programming paradigms, usually 4 topics need to be covered, like including imperative, functional programming, object-oriented programming, and another one that's concurrent programming, that's a parallel processing. But parallel processing is too much for this course. So our Unit 3 do not cover the concurrent programming, okay? Do not cover concurrent programming. So I would suggest you to take a separate parallel processing course for it, okay? But these are different programming paradigm. And we pick Python because Python has every feature here, okay? And then this is talking about programming paradigm. So some programming language course, they use a Smalltalk or Java to talk about object-oriented programming. They use Lisp or Scheme, okay, for functional programming. And then they use C, C++ to talk about imperial programming. They teach a lot of different language in one single semester, just only to demonstrate different programming paradigm. Okay, but that I think is actually too much. Okay, we cannot teach so many languages. So if you want to learn more language, you should learn it. Okay. So this course we are, I would say 90% on Python and maybe 10% on Scheme. Okay. And Scheme or Lisp is a similar. Scheme is one kind of Lisp language. Okay. So we primarily depending on that. So these first few units, we are on the basically on the program using the program language to talk about different programming paradigm and the memory model and data type. Then Unit 4 is talking about once you have those features designed into your language, then how can we write a interpreter or a compiler for that language? Okay, for that language. So we will talk about different stages of the compiler, including synthetic syntax analysis, okay, and then scanner, okay, and then semantic analysis, and then how compiler is being done, okay. So these are from chapter 9 and beyond to chapter 16, okay, 16 week. Okay, so these are how these courses have been organized. And then what is the textbook? So the textbook, we choose two as the main textbook. So if you want to expedite most of the homework, where did it come from? It comes from this book. Okay, this book. But this book is not organized in the same order of the chapter as ours. You have to jump around to figure out which chapter you need to read. Okay, so our course share do tell you where you need to read, okay? But if you have question, you can ask me where you should read for each homework or quiz, okay? So that's a programming language edition 4. Another textbook is this one, MIT's Structure and Interpretation of Computer Program. So right here, you can see that the name is the same as the name of our subtitle. Okay, the name of our subtitle is The Structure and Interpretation of Computer Programs. So why this topic is important now? Okay, that's your question. And we do have this. So this one, I believe that we do have a link for the third edition textbook PDF you can download from internet. Do you need the newest version? I would say probably not, because you just need to read the material from the chapters. So if you can download from internet for some free PDF, I'm fine. Okay, I actually encourage you to get a textbook, but I will say that's not a must. Okay, it's actually optional. And second textbook, this one actually it is written in Scheme, but they do have a JavaScript version. But we are not using JavaScript version. We are not using Scheme version. We are using Python version. So where to find the Python version? So to find a Python version, you can actually go to the internet to search for structure and the interpretation of computer systems, computer programs using Python. So click this one. Click this one, you'll find there's an introduction and SICP. SICP is a structure and interpretation of computer program in Python. So you click this one. And you will got a free textbook. So this one is a free textbook. Let me copy the link and pass it in the chat box. Okay, a copy over here. So you can also find a link from the course shell, but this one is a Python version, and you can read it for free. Okay, you can read it for free. Okay. Okay. Anyway, I'm sorry. So this course is SICP in Python. And then it says that CS61A online textbook. Okay, so what is CS61A online? This one is CS61A, okay, structure and interpretations of computer programs. So this one is a Berkeley course. Okay, they do have course share online. You can look at it here. And then their course description is right here. Okay. So are we 100% the same with them? No, I would say no. We probably is a combination of this 61A and the programming language textbook we talk about, the Michael Scott textbook. So we are kind of combining the two together to create my course shell. Okay, so it's combining the both curriculum together to maximize your learning experience in the topic. Okay, in the topic. Okay, so these are the textbooks. And then the schedule. Okay, this one is an old schedule, so I don't use this one. The schedule is sorry, I'm rendering some videos. Sorry, I'm in trouble. Oh, another here. This is schedule 2025. This one. Okay, so the schedule is this we listed in our syllabus. Okay, so if you don't get it, you can read the syllabus section of the course. And in each week we have some topic. Okay, so we basically talk about which week we would be on what topic. Okay. So basically, you just depending on the course shell. Our course shell is well designed. The only known problem that my course shell had right now is that somewhere in the scheme language, the week 9 and week 8, probably one problem should belong to week 9, but it actually show up in week 8's quiz, something like that. Okay, that's the only problem we have. So you do see that you can wait for 1 week to turn in the quiz. Okay, I'm fine for it. Okay. And don't worry, okay, don't worry. If you do see something that you haven't learned, you can actually read the next chapter in order to solve it. Okay. So that's only one thing I know. And I don't have time to redesign the course shell right now. Okay. Usually after 3 year, 5 year, I will update it. Okay, anyway. So this one is about the schedule that we have, and we are following the course order we talk about, okay? The data type and memory model. programming paradigm. Up to here is a programming paradigm. And then next one is the implementation of a compiler or interpreter. That's from lexical analysis, syntax analysis, interpreter design. Okay, everything right here is for the programming language structure and compiler design. Okay, so these are the schedule. We divided into different weeks. And the next topic I'm going to talk about is the grading policy. Okay, grading policy. So as you can see from the syllabus, okay, this number may be not correct, but we can use it anyway. You will get some point from your quiz and assignment and the discussion and the final project and project 1 and project 2. Okay, and there's a proposal as well. You get a lot of assignments, so each one you get certain point, maybe 200, maybe 150, maybe 20, maybe 40. And at the end, we sum everything together. So the total number of a point would be 4,500 point. Okay. And then see how much you get. You may get a certain point. Okay, you get certain point. And then there's a 500 bonus point out of 500. That would be a current point. So this current point, I will assign it for the whole class at the end of the course. Okay. Then some student would ask like, okay, how am I going to determine the curve points? Okay, my policy is very simple. Because usually some student may need help in terms of grading. Okay, but we do have to set up some limit. So my goal is to control the A group of the people. Okay, A group of the people. I try to control it from 1/3 of the student to 2/3 of the student. So usually when I do the curve point, I try to find a curve point, maybe 200, maybe 300, maybe 150. So that students get somewhere around maybe 2/3 of the student will get A or A minus. This A means A or A minus. So maybe another 1/3 to a half of the student may get B or below score. Okay. Any question about it? Because I believe that if A is over 2/3, usually that's too much. Okay, too many people get A, then that course is actually out of control. If A is dropped below 1/3, I believe that that course is too strict. Then student, no matter how they learn, they get too much discouraged. Okay. So this curve point usually we based on the students' class attendance records and also group discussion record, we actually give a curve point for the whole class. So basically, everybody the same. If I assign 250, everyone will be 250. It will not be one guy 300 and then one guy 100. No, we don't do that. We actually, this curve point is curving the whole class. Okay. Any question? Hello, any questions so far?
No.
Okay, so that's the breakdown. Usually we use this table to assign a final grade. Okay, so you basically use your total point you earn plus the curve point, okay, divided by 4,500 base points. The curve point is not included in the base point, so this one is kind of like a bonus to boost up your number, okay? Okay, now one question. when does the homework due? Okay, so every week we have something due, okay, and then you need to base on the description on the code shell. But we have a general rule of the due date being the last Sunday night of the last week. So for this year, okay, this year, our last week of the class is actually on May 10th. Okay, so May 10th. Let's look at the calendar. So May 10th is supposed to be the last day of the class. So our real due date is May 11th. That's a Sunday. Let me check one more time, okay? Double check. May 11th is a Sunday. Yes, that's a Sunday. Okay, it is a Sunday. So May 11th, Sunday night, 11:59 p.m. Central Time. Okay, don't tell me that I'm living in East Coast or Hawaii. Okay, Hawaii. I don't care where you live. Okay, we use 11:59 Central Time. So that means the end of the Sunday. Once you pass it, I don't take any homework anymore. Okay. But say if you have let's assume that you do have a week 3 assignment. Let's assume this week 4. Okay, I'm sorry. You have a week 4 assignment. This 150 point week 4 assignment. Okay. You do not submit it, but you submit it just before 11:59 of the May 11th, then I'll take it. Okay. So they homework are always accepted. They homework are always accepted. They quiz also always accepted. But they homework I may deduct if you are over 2 weeks. I will say you are past due too much. Okay. Over 2 weeks, I may give you minor deduction, maybe 10-point deduction, something like that. Okay. But not a lot, not a huge deduction. Just to urge you to catch up. Okay. Is that okay?
Yeah,
But
that's
say if you can turn in everything on the last day, I'm okay. I don't care when you actually submit your homework. I will try to give you the maximum flexibility because some students tell me, oh, my grandma is sick, okay? And then some people tell me, okay, my son have some have a little son, okay? Some student have little son or little daughter have a birthday. I have to miss my Sunday this week to submit homework. Okay, that's fine. I don't care. You can be late, but if you are over 2 weeks late, then we may give you minor deduction, maybe 10 points, okay, usually. And then if you just before the Sunday night, 11:59, you submit it, I will all grading them and you will get your score, okay. But if you are over it, say you somehow just forget to submit and you kind of like Monday morning, 8 p.m., you wake up and you actually forget to submit some homework. Sorry, you are too late. I don't take it anymore. Okay. So why I'm setting on the Sunday night as a cutoff, just because usually the Tuesday, okay, Monday, Tuesday, and Sunday. Usually Tuesday 10 a.m. Central Time, the Lewis University administration require every professor to submit the grade report. And this 10 a.m. Central Time is actually 8 a.m. of Pacific time. That's my time. Okay. So I'm not able to turn in at this time. So usually I turn in in Monday. And then before I turn in the grade, I need to tabulate the whole thing, right? And then I need to actually calculate your grade. I need to make sure everything and curving is being added to the final score. So I need 1 day to work on it. That's why I use a cutoff of a Sunday. Okay, Sunday night, the end of the Sunday. Is that okay? Please allow me 1 day to work on it. So if you say I turn in Monday, sorry, I have been starting tabulate everything already, and then I need to be fair among students. So I cannot take yours, but don't take others. That just I just cannot finish my grading. Okay, so I have to use the Monday, the whole day to do it as a buffer. And then I need to turn in early morning on Tuesday for it. Okay, sorry for that. That's required by the university, not my own law. Okay, not my own rules. Any question about the whole the grading policy? No.
Hi,
Oh,
Professor. I have a
yes.
question.
Go ahead.
Because I'm taking a lot of classes this semester, so I might like fall behind. When do you start taking off points?
2 weeks.
2 weeks. Okay,
2
gotcha.
weeks. If you are late by 2 weeks, I will take off minor point. But just before the end of the course, just before anything submitted before 11:59 Sunday, May 11, I will all take them. So you'll get some point. Maybe this one 150, you may get 145, maybe. You may get 140, maybe. But you don't get 20 just because you are late.
I see. Thank you.
Okay.
Mm-hmm.
So basically, give you a minor penalty, but I'm not going to kill you just because you are late on a homework. Because many of the students I know is actually part-time reading, study for the bachelor degree. Okay, so I'm not trying to give you the same standard as the regular 4-year university student. They actually started as a freshman or started when they are 18. Okay, I know that many of you are more mature than the regular like state universities, right? I don't know. My experience is like that. So I would try to give you the flexibility to handle your own life, your own study, okay? And another question, can I submit the homework 2 weeks early? Yes, it is welcome. So if you know my course shell is on before the semester start. So you submitted like early, like 2 weeks before, or even 3 weeks before, or you finish the whole course in 10 weeks, and you are going for Hawaii. Is that okay? That's okay. I don't care. Is that clear? Finishing early also okay, but finishing early you don't get bonus. You don't get a bonus point. We don't award early birds any point. Is that okay?
Yes.
So we try to be very flexible. Okay, try to be very flexible, but not because it's flexible. So you actually try to copy. We don't actually honor anyone who copy or actually involved in some sort of plagiarism. I don't like people to copy homework. We give you the maximum flexibility, so you should try to create your own work, not trying to copy from someone else or past years students' homework or something like that. Okay, it's not good to do that. Is that okay? If someone cannot pass the AI's detection of the copy issue, then I may give him 0, okay? So no tolerance in if you just copy your homework from somewhere, or you completely using the ChatGPT to generate your homework, it will not be welcomed, okay? Even though ChatGPT is so popular right now, but we don't welcome you to do that. We want you to learn the fundamentals. Is that clear?
Yeah.
Okay, so try your best. And because I also tell you, if I will control the A to be around 1/3 to 2/3, okay, of the student distribution. I try to control that. I have been teaching this course for maybe 8 years or 10 years already. It's quite many years, maybe 9 years. And then we are using this model quite successfully, okay? And usually I would say if you submit every homework, every quiz on time, and you actually do it well, usually got an A, okay? Usually those students got B or score below has missing homework, okay? Has missing homework. Usually are those students who have missing homework, or his quiz all fail. He didn't study anything at all. Usually are those kind of students. As long as you study and you actually study reasonably, they may be minor deduction, but they usually don't take you down to B or C range, okay? Okay. And because I want to be flexible, so I don't actually give you the pressure of you must be due at any time, okay? I don't believe in those kind of deadline pressure education model, okay? I don't think that helps students to learn. Students are learning the best way when they have the maximum flexibility and they are willing to study at their best. I think that will provide the best education environment, okay? Any other question about grading? No? Okay, if no, I'm going to go over the projects and project and also the course share. Okay, let's talk about project first. So this course has 3 projects. Project 1 due right here, you can see it's due on week 4. Project 2 due on week 9. And then final project proposal due on week 10. And then final project due, okay, final project you have a proposal due, you also have a term project due. So these are 2 due for the final project. So total is 3 project, project 1, project 2, and term project, 3 project. Okay. And project 1 is worth of 200 points, project 2 300 points, and proposal 100 points, term project 700 points. So term project and proposal, this combined is 800 points for the third project. So this one is really huge item for the course. Okay. Okay, now question 1. Can you do project 1 and before you finish, you start project 2, and before you finish, or even in the week 1, you start the term project? Is that okay? That's okay. We don't care when you start it. We only care about whether you submit it or not. Okay, and as I said, all of them, if you are past due, you are late, and then you submit before the end of the semester, that's still okay. You may get minor deduction of 10 points here, maybe, okay. Or this one project, I may deduct 20, okay. Well, it still be a minor deduction, okay. It won't give you, usually, you won't, it is 10 or 20 points, okay. This project is bigger, so maybe 20 points. But anyway, won't pass the 10%, okay, of your score. Okay, but anything due, okay, if you submit the term project first, and then project 2, and then project 1, is that okay? That's also okay. You turn in reverse order, that's also okay for me. I don't care. As long as you submit it, okay? As long as you submit. So give you the maximum flexibility. There is no requirement that you must submit which one first, which one later, okay? But I told you the weak number, that means that you need to find the submission point at the code shell of that location, okay? Okay, so project 1 is on sorting. Sorting algorithm, comparison of sorting algorithm. So project 1 will expect you to memorize, try to write the sorting program by yourself. Don't try to not to copy from anywhere else, okay? Because you already learned the data structure and the algorithm. You should know about the sorting algorithm. You should try come up with your own sorting algorithm by memorizing it. If you forget it, you can look at it, look at the example for more time, and then come back to write your own code, okay? Project 2 is on try and dictionary. So it's a data structure. Okay, so this one also is a very important topic. Okay, so these two actually you have to study to write your program. Okay, now final project. Okay, let's talk about final project. So final project is usually more question come from. So what is our final project? Our final project actually is usually a open topic. Okay, open topic means that you can do whatever you want to do as a term project. Okay, even though we say everything you can do, but it still have a boundary. It need to stay within the boundary of the programming language course. So what is programming language course? What is the main topic in this programming language course? I would say if your project involves some sort of language translation, say you translate one language to the other. Okay, let's look at the compiler, right? Compiler, actually you have a compiler, and compiler is compiled from C++ language to machine code, right? Interpreter is actually interpreting from Python to some sort of Python virtual machine code, right? Okay, so your term project is acceptable as long as you translate from some sort of A language to B language. Then that's fine. Okay, you translate from one language to B language, that's actually fine. So this is very big and open definition of the programming language. So let's see. So right here, if you look at the computer science level or interpretation. Okay, your computer science have multiple level of the interpretation. It can be from high level language to intermediate language, then from intermediate language to machine code to transistor level design, transistor level gate level design, gate level to transistor level design, transistor level design to physical devices of the semiconductor, right? So any level of the translation is okay if you want to look at it. Okay, so project idea is open idea, anything that can do. But if you want me to suggest, you can try scheme language interpreter. These are just suggestions. You can take it or you don't take it. It's either way, okay? We don't force you to just do these three topics. If you cannot find anyone, so we pick one for high-level language interpreter. Or you want to do hardware design, you do single instruction assembler to try to design an assembler. Or you want to do AI, so you go GeoJSON visualizer that translate from this GeoJSON data format to a geometric object drawing. That's also okay. So from language to visual drawing, that's also okay. So let's look at what is AI. AI, okay, AI. Nowadays, when we talk about AI, computer vision. So computer vision is you kind of input some image, or if your car is running, it actually coming in with some video. Okay, and you do labeling. So you do CV computer vision, you label on a lot of cars here, there, in Tesla cars, right? And then you output your environmental model. So it's a pattern recognition and also try to identify the object in your picture. That is also a interpreter. In a way, that's also interpreter design. It is involve pattern recognition, involve pattern matching, involve language translation from image to a language model or environmental computation model. Is that okay? So in a way, AI by itself, it is a language translation. So for example, you translate from Spanish to English. That's also translation. You translate from C++ to Python. That's also language translation. So any kind of translation is the topic of our programming language. So that's actually acceptable. Acceptable topic for our term project. Is that clear enough? Hello, is that clear enough?
Yeah.
But as for what topic to pick, I just give you suggestion. I don't actually force you to do anything. It's up to you. So this one, we also test you on your creativity. See if you are creative enough, okay, to do it. So interpreter or one instruction assembler. These are just suggestions. Or GeoJSON visualizer, okay, whatever. And now, week 10, you need to try to submit a 100-point proposal. Week 16, you need to try to submit a final project submission, okay? Question? Any question? No? Okay. So the purpose of the proposal is to try to, you are thinking about this way. You are in a company and you make proposal to your manager to earn funding. So you are trying to learn how to make proposal to your manager. Okay. So when you try to prepare a proposal, we talk about what you want to do. You need to cover what you want to do and how much resource you need. I need a computer, I need software, I need whatever time, and your schedule. So this proposal need to cover your overall thinking of your project title, idea, project deliverable, tool, material, and schedule. If you miss anything, you got deduction, okay? So this is what required by the proposal. The purpose of doing this is to train you so that later when you go to a job, you know how to make proposal to your manager, okay, to earn some funding for your project. That's some training that you needed to make proposal to your manager. So in this one, should you write a lot of references for some research paper? No, that's not a key point. We are not doing research right here. As long as you can talk about your project well, and what is your deliverable, your tool and schedule and material, that's fine. So in the past, some students just give me 3 sentences. That's not good, okay? That's actually too short. Some students give me a 30-page report. That's too many, okay? I cannot read so much. It's just a proposal. How are you come up with the 30-page proposal? You just copy from somewhere. We don't need that, okay? So usually 2 to 3 pages of the proposal is good enough, okay? So you submit a PDF or you submit the Word file, that's fine, okay? Okay, that's a proposal. Now, next one is a final report. So proposal is something that you propose to your boss that you want to do something. Final report is where after you finish your project, you will do presentation, making sure that you can have a good report to your boss, right? Okay, so that is a different story. So there's one question. If I make proposal to work on the robot, whatever topic I want to do, okay? So I work on A project, but later I change my mind. So my final term report, I write B project. Is that okay? That's okay. When we grade your B project, we don't look at your proposal. Okay, it's a totally separate issue. Is that okay? But of course, we are expecting you to write a proposal for your own term project, okay? Don't copy from somewhere else. Again, if you copy, we will give you a very low score, okay? Is that okay?
Yeah.
Okay, now in the final report, let's talk about final report. So final report, you already finished everything. You need to write a technical report. You need to make a presentation. You need to include all your technical files. So technical file, including your program and design schematic, there's no problem. Okay, usually students don't mess up right here. So presentation, okay, presentation, you give me a PowerPoint, Google Slides, or YouTube link. Either way, or combine, it's okay for me. Okay. But in your PowerPoint, do not write a lot of equation and theory and those kind of things. I don't need that. I just need, in the presentation, I just need you to show people what you have done. Who could answer 2 questions, what you have done and how it works. We only care about this in the presentation part, your PowerPoint or your YouTube link. You can do demonstration on YouTube, okay? And just give me the YouTube link. Don't send me the video file, okay? So this is your final presentation. As for the written report, if you got some theory, some discussion, some technical discussion that you want to say, You want to write a 10-page report, that's okay, but put it in the final report. Do not put it in your PowerPoint, okay? It's a separate issue. Final report is to show me your thinking, your technical discussion. Put it into your final report, that's fine. Presentation is just to show people what you have done and how it works, okay? Don't give me a lot of words, small font word in the presentation, okay? It is not a good presentation, okay? Is that okay so far? As long as you can show what you have done well, that's quite good enough, okay? So that's the final report. So all of the term project or project, the grading is final. We don't negotiate for the grading, okay? So, and grading is subjective. We never be able to be objective or neutral at all times. So you have to know that it's a human eyeball viewing. So I may make mistake. I may be not neutral, not objective. That's actually possible. I try to be fair, but I cannot promise to be always accurate. Okay. But that's the way the real world is. You have to try to convince me that you actually really spend a lot of time on it and do a good job on your project, including in your proposal and also your presentation. Okay, try to make sure that I can see what you have done and how it works. Okay. Okay, but we try to be fair, but we cannot promise that we can always accurately reading that you are working hard. Okay, we try, but we may miss. Okay, is that okay? So we judge based on your originality, creativity, completeness, technical difficulty, and your presentation on your final project. Okay. Any question about the term project?
No.
No. So the topic is up to you. You can choose any topic related to programming language translation. That's fine. Okay. But if you say you copy an AI program for me, sorry, I don't need to learn AI. Okay. We are programming language course. We are not machine learning course. Okay. I don't need to learn machine learning right here. Okay. So don't copy those kind of project to here. Focus on language translation. Okay, so this is term project. Any other questions? No? If no, I'm going to go over the course shell. Okay. Okay, so every year we have this course shell. Okay. So you start with the syllabus. Okay, there's a syllabus. You can look at the syllabus and textbook link. Okay. And then there are project description as well. So you started from the week one. So that's assume that you started from week one. So week one, there is a topic, the learning objective there to learn to do this. So these are just a short description. So you get started from this instruction material. So everything that we teach, we do have a video right here. So please watch this video. So each of the video maybe is 2 hours long or 2+ hours. And in reality, if you want to finish the whole video, it probably take 5 hours to finish. Because you need to study, you need to understand it, okay? So basically, please watch the video, okay? On Monday, we cannot teach you too much. We basically give you a chance to do question and answer. Okay, we basically give you a chance on Monday. We usually just go over some main topics and then give you the basic guideline of what you do in the next week. Okay. And then we go over it. But if you want to go to the detail, you have to watch the video because this is a lot of things we cannot teach you in the online course, the Zoom real live session. That's too much. Okay. So number one, you have to watch the video. Okay. And Monday, usually any question you can bring it up. Okay. On Monday, we will talk about it. Okay. Okay. So this was about the video policy. And then there are study material as well. They tell you the lecture PDF. Okay, whatever. And then assignments. Okay, so each week's assignment is over here. Okay. So some of the link maybe it's actually broken. Okay, they do automatic translation for me. In the past, actually, I do have a master share course share in the older Blackboard version. Okay, so in the past, this course looked like this. It's an 8-week course, so they do automatic translation for me into the Ultra, the new course share format that's called Ultra, Blackboard Ultra. So Blackboard Ultra look like this right now, but I'm not sure that they may have a missing link. Okay, so if you feel like there is something missing, just let me know. Okay, is that okay? Because they do the auto conversion from one version to the other, so they may make mistake and may miss some linkage. So if you do see something that's loose, let me know. I will actually give you the link that you need. Okay. And also, if you would like to look at the past year's recording, okay, they give you what year, what session, what year, what session, what year, what session. Okay. And as you can see, this course we have been teaching for quite many years, starting from 2017. Okay. I have every year's video recording. And then as you can see right here, starting from 2022, we started use a SCIP version. Before that, we are using the programming language schematics, the what's that? Pragmatic version of the curriculum before that. So 2022, we start to use this new curriculum. Okay. So these 3 years are more useful to me. Okay. Okay, so that's about the course shell. Any other questions so far? Any other questions so far?
No.
Okay. Okay, if no question about the term project and course shell, next one, I'm going to briefly go over the week 1 material introduction. Okay. Okay, so week 1 introduction is talking about the introduction of this course. So basically talk about what is programming language. So this one I think everyone is fine since most of you are junior or senior student. So you do talk about the history of language maybe. Okay, that's not a problem. And then you need to learn what's different programming paradigm. Okay, what is declarative programming, that's imperative programming. And then you need to know what's functional programming, data flow programming, logic programming, manual machine, object-oriented programming, scripting. Okay, you need to know about the difference of these different things. Okay, so this tell you what is the different programming paradigm. Okay, so this course we talk about the first half is on programming paradigm. So basically, you need to learn the features of these different programming paradigm. And Python all support them. Okay, Python had a functional programming. Python also has the imperial relative programming feature. Okay. Okay. Anyway. Okay. So this programming paradigm is the first thing you need to learn. Okay. And because we are also maybe you also will learn data science or the machine learning later. So data flow idea you also need to learn. Okay, you also need to learn what is data flow programming. And then we'll talk about the interpretation of the computer programs. So talking about what is compiler, what is interpreter. Okay, you need to learn that. And also need to learn what is virtual machine. You need to understand what is a virtual machine. Okay. So by the way, anyone know what is a virtual machine? Why we have the virtual machine for Java and Python? Anyone know? Hello? Anyone know what is a virtual machine? No one?
I do.
Okay, you talk, go ahead.
You said what is a virtual machine?
Yes,
Isn't it just another machine like on the computer that like handles what is it, like the virtual memory or like the cache and stuff like that?
why do we need it?
Why do we need it?
Yeah,
I personally, the only experience I have with it was from previous classes, and what we needed it for was for like to be able to run different operating systems like Linux.
yes. So the key word is your language you want to be platform independent. You talk about a keyword, that the right keyword is platform independent. So basically, you have virtual machine. So your virtual machine, say your language is Java. You got compiled to that class file that's actually bytecode. Okay, so bytecode can be uploaded to a Java virtual machine on Windows. It can be loaded to a Java virtual machine on Mac OS. It can also be loaded on a Java virtual machine on Android OS. So basically, your program can be run everywhere, but Java virtual machine handle the issue with the hardware. They do have different version, but your source code can run at any of the computer without being compiled separately to different machine code. So that's the purpose of the Java virtual machine, to make your language become platform independent. Do not depend on your OS. Is that okay? Okay, so this virtual machine is very important, okay? To create a code that can be run on different environments, okay? So virtual machine, Java virtual machine itself is a interpreter, okay? It's an interpreter. So they talk about different way of doing compilation, okay? So different way of compilation. They talk about the topic. You can go over it, okay? We also talk about different way of interpretation. Okay. You need to learn all the term. Okay, next one is a programming environment. Programming environment means your tools. Right here, we are talking about old times Unix or Linux tools. You need to know about a tool for building your software. Okay. So here tell you each IDE support for what. Okay. And your maker, C maker, okay, C make, okay. Nowadays, you may also need to know what is GitHub, okay, what is GitHub. Version control, okay. GitHub workflow, you need to know about how things work, okay. And then we talk about different stages of the compilation. As I said, this is the second half of our course. So this introduction part talk about what different stage work, how different stage work in the compiler. Okay, this is the second half of the chapter. Okay, whatever, you can watch the video, okay? And then we do different kind of parsing and scanning to generate a parsing tree. Okay, this is the end result of a compilation. Okay, this give you the basic structure of how your expression got lexical analysis into tokens, and then you do syntax analysis to build a parsing tree. And then finally, you generate the machine code. Okay, it's a compilation process. And then in the past year, we also talk about Flex and Bison. These are compilers, okay? So compiler, I believe that in 2018, as I said, if you want to look at the video that on the compiler, you can look at 2018 or 2018. We do have the whole playlist. They do cover a week on compiler, okay, I see. Now listen, let's look at the 2017, okay. Probably in 2017. We do have the whole session talking about compiler, Bison, okay. Okay, yeah. No. Yeah, right here. Bison, okay. Bison. We have a whole week to cover Bison and Flex about how to do automatic compilation. Okay. Compiler generation. Okay, so that's the Bison part, and talk about this Bison generation rules. Okay, that's about what is chapter 1. So chapter 1 basically go over what are the languages, what are the language feature people may look at, and how compiler and programming language course is, okay, for different stages of compilation. Okay, so this is a short, brief go over of the chapter 1. Any questions so far?
No, no questions.
How about any question about your quiz or your homework so far?
No, none at all.
No? Okay. So now the last thing I would like to talk about is the way to contact me, okay? Number one, you can go through this message part. I will read it, okay? That's the first thing you can go through here. Second, you can shoot me an email, okay? So my email address is ECHOU, okay, E as my Eric, CHOU is my last name, at Louis University.edu, okay, this is my email. You can contact me by this way. Or if you want to send to my personal email, is ECHOU 510. 510 is my area code, Fremont's area code, okay, at gmail.com. Okay, you can shoot me email like this, okay? Or if you like, you can also give me a message, okay? So you can come to this one. My Facebook page is Facebook/Dr. Eric Chow. Okay, very simple. My tag is very simple. And then add me as a friend. I'll grant it. Okay, request as a becoming a friend. LA. So Facebook/Dr. Eric Chow. You'll find my page on Facebook, and you can shoot a message to me if you need it. Okay. So if you want to ask me question, this is also one way to. Usually this one is faster. Okay, because I read the messenger every hour, almost every hour. If you shoot me an email to Louis, I may not read it. I may read it 2 days, 3 days later, okay? Because I'm not full-time at Louis, so I don't read email every day, okay? So the best way to shoot me a message is through here, the messenger, okay? Any question? Or if you need to call me, my phone number is 510 304 9428. Okay, you can also call me if you do have something urgent. Any questions so far? No?
No.
Okay, if no, I finish whatever I want to talk about today, okay? Or but if not, then we will see you next week, okay? Any question?
No.
No? Okay, see you next time, okay? Bye-bye.
See you. Have a good day.
Bye-bye.
Thank you. Have a nice
Bye-bye.
day.
Bye. Thank you.
Bye-bye.